We like to bring him in during tropical season. Andrew Austin-Adler, he's a meteorology student, really good with the tropical stuff. Yeah, so I guess we've given you a little break here. You've been on hiatus during severe weather season, but now we got some buzz about this action going on up in the Northeast Gulf coming up sometime between Sunday and Wednesday. You know, I've got a lot of model data which we can jump into, but how about just some quick thoughts on whether this goes down or not?
Well, that's a very interesting question because this is a very tough forecast. It's one of those, as we like to call, trough splits, and the forecast for those is always very finicky. So basically what's going to happen is we're going to have this trough that kind of moves over the northern Gulf, and we'll sit there for a little bit. And, you know, there's been a lot of discourse on Twitter about, is it going to form? Is it not going to form? And, you know, the models are showing this, the models are showing that. Well, here's the thing. There's currently a big ridge, which you showed on the last block, over, you know, the western United States. That's going to retrograde even further west. And as it does so, there's going to be East Coast troughing that builds in. And when that happens, whatever disturbance that we do have over the Gulf is going to quickly move inland. And before it does that, the low-level flow is going to be what we call undergo what we call deformation, which is basically when any ambient vorticity down there kind of gets stretched and strung out like taffy, which makes it very difficult for the disturbance to aggregate that low-level vorticity and stretch it into a tropical cyclone. Yeah,
this is kind of an interesting setup. We had Andy Hazelton had a good tweet about this. I don't know if you guys want to pull that up real quick. But he was talking about how he was looking at really the ridge is kind of the big player in this. So like this ridge that you were talking about. And he said these setups are tricky. You know, a lot more ways for them to go wrong, meaning no development than right would be a tropical cyclone forming. This is from the perspective, of course, of a tropical cyclone researcher. He said it's still worth keeping an eye on. But the thing that really stuck out to me about what he said, and for the viewers here, we're looking at the upper level pattern. I use this map a lot. I'm going to use it even more tonight. And you mentioned this. You got the ridge in the west. You got the trough in the east. And as this ridge kind of breaks down, you get the trough that develops. Now, this is the first thing that kind of makes me think this doesn't seem like a typical tropical setup type of situation. This is more of like a large-scale synoptic feature where I have a high amount of confidence that there's going to be an area of low pressure that develops. But, I mean, this thing's going to probably sit up just pretty close to the coast. You know, I don't know that I don't think there's even going to be that much wind shear around. But the question really, and tell me if you agree, is it going to have time to sit over open water enough to become a tropical system? And it's probably going to be no.
Yeah, the answer is absolutely a resounding no. If we were going to see it try and develop, we would already have a disturbance there right now. Once that trough really starts to influence the region, any disturbance there is going to get pulled pretty quickly northward onshore.
You know, I think we're going to have enough moisture around. I mean, the water temperatures are pretty warm. And, you know, here's kind of an interesting thing. A lot of people have been posting these AI models. And the European AI model does think a little something might form. I mean, I guess it has more of the members of that forecast model showing an area of low pressure that develops. I'm going to show some of these on here, and this is the AIFS ensemble. It's basically the European ensemble. So tell me, as an aspiring meteorologist, you're looking at this here Saturday morning. Why should we not be concerned about this? That's a lot of L's right there.
That is a lot of low pressures, and the reason why you shouldn't really be concerned is low pressure area does not always equal tropical cyclone. You can have all different types of characteristics with low pressures in this region. And also, a thing that really sticks out to me is that the Google AI isn't really catching on to this at all. And that's been pretty well with sniffing out these kind of homegrown systems.
Yeah, so I'll show these each individually now. Maybe, you know, everybody learns a little bit differently. Some people like to look at the bunch of L's of the ensembles. I'm just pulling up the like the deterministic version of this model, I suppose. And actually, you know, I'll tell you what, I think the newer run of this has come out and it doesn't even look quite as impressive. So this is like Friday into Saturday into Sunday. And for the viewers here, like I'm just basically looking at like how significant of a bullseye am I getting on the lines here. Those are basically lines of geopotential height. And that actually kind of looks like a broad area of low pressure. So maybe the Euro's backing off on this a little bit. Let me actually go back over to the ensembles. This is the AI Euro ensembles. See, this would be a little bit more of a look where a model is trying to show a tropical system developing. So that's really the one model that's showing it. You mentioned the Google AI is not showing it. That's the one that has been doing such a good job. especially during the season last year. And then I've got the GFS AI here, which honestly, I can't believe I'm saying this, but I think this has a pretty reasonable look with it. Kind of you see just a big old broad area of low pressure. It's not like a really tight area of low pressure. Doesn't look tropical to me. Moves inland a little bit, then a front will come and push this whole thing off the side.
Exactly.
Yeah, exactly. Okay. Yeah, I mean, there's nothing else to say. I mean, I forgot. I should have brought him in, but I ended up just continuing to talk myself, which I have a little bit of a problem with. Thank you for your patience. All right. What do we think? Are we done? Is this enough with this thing? Yeah, I think we've given it all it really deserves. Let's move on to El Nino. I'm curious your thoughts about this because I feel like I've been saying this for a while. I feel like El Nino, people don't really understand what it is, and the headlines are always just El Nino is going to be huge, and then everybody just assumes that all means bad. In so many different ways. Obviously, it's not bad in every way because it's going to keep the Atlantic season a little bit quieter. Is there any, what would be some scenarios that you could see where maybe the Atlantic overcomes the influence of El Nino? Is it the homegrown storms? Is there a certain time of the year where things could be a little worse than usual?
Well, I think there's a very interesting case about that with the most recent El Nino, which occurred 3 years ago in 2023, right? We had very anomalous warmth out in the Central Pacific. It was, a pretty strong El Nino, but to the degree that we had warmth in the Pacific, we matched that, even exceeded that in some spots in the Atlantic Basin. And I think that kind of combated the effects of El Nino a little bit. If you remember, we still had, despite the El Nino, a very above average season in the Atlantic that year. It is a different story this year, though. We have what's called a negative AMO, which is, cooler than average temperatures in a certain area in the Atlantic Basin. It's basically just not what we saw in 2023. I mean, the only way that I think we could really pull ahead and still observe an active season is if we get something significant in the southwestern Atlantic where we have the warmest waters.
Yeah, exactly. I mean, you look out here in the main development region, and I think if we were to see anything counteract El Nino, it would have to be warm sea surface temperatures or something like that. Because, the thing with El Nino is basically the number one reason why it makes the Atlantic hurricane season more quiet is because it really strengthens the subtropical Pacific jet, which comes across here. And so you're getting all these storms that are trying to come across from the east. Tropical systems don't like to get different directions of wind way up high. Thunderstorms over land like that, it can actually help those storms to maintain themselves for a little bit longer. But anytime you're just seeing different directions of air or different speeds as you get higher up, it's just wind shear basically, and these storms just get shredded up like they're going into a paper shredder. But sometimes you can get a little bit of a low in the shear, and if this water's warm enough out here, you could still overcome El Nino. But the problem is we don't have warm enough water out there, so I don't think that's going to happen. Hey, let's do the crown flash here real quick. You guys ready for this? We're going to play a video here for you. Check this out. You ever seen one of these?
What the heck is that?
What is that?
I don't know, but I'm zooming in on it. It moved. What? You know what it looks like?
What?
It looks like a magnifying glass. See, it's moving again. It looks like when you focus a magnifying glass.
Like a gap or something?
No. It moved again. Wait. Hold on.
What is that?
Film. What
Whoa.
the? Is it ice
That's
crystals?
cool. That's really cool. I've never seen one of these with my own eyes before, but have you heard of these before?
I have not. I honestly have no idea what that is.
So this is so cool. Let's take Max because I'm going to draw on this. We'll do it together. Luckily, earlier in my career, I've had to cover this before, so trust me, I had to do my own research on it. It's not like I knew this. But what's actually happening here is it has to do with the electrical charge that's in the storm. So first off, you have to have the sun that's shining through just at the right part of the storm. That's why it's kind of rare. It's usually on the edge of the storm where you got some extra ice particles. So imagine, I'm going to pause this. You've got a lot of little vertically oriented ice particles, and then you've got these electrical charges rather than straight up lightning that goes to the ground. Sometimes those electrical charges can flip, and then it flips the orientation of the ice particles super fast. So, for the people watching this, I mean, I think a good way to think of it is when you put metal stuff in between a magnet, it can just instantly change its orientation. That's what's going on with the ice particles up there. So there you go. Oh my gosh, I actually taught him something. That's crazy. Cool. Usually I'm learning from him. Andrew Austin-Adler, AAA, our our go-to for tropical information here on Fox Weather at Night. We appreciate the time. I know you're on vacation. You took this on short notice. What a bro. We appreciate it, man. Have a great night.
Thank you so much. Anytime.
All right. All right, that was cool. I like the crown flash. That's a lot of fun. That's a good one. I had to re-research it a little bit. It was like